Okay, so looking at this problem, you want to find this indefinite integral. You're going to use the technique that you're going to do. Again, there's no quotient rule for integrals. The technique we're going to use is a u substitution. We're going to let u equal x plus 4, because that would just give us the square root of u in the denominator, which is a little better to deal with. But if we're going to do a substitution, we've got to get rid of all the x's and express them in terms of either u or du. So I'm going to take du, the derivative of u. The derivative of x is just 1, and then you'll have the dx. So this is du is dx. Now when I go to substitute, I'll be able to replace the dx with du. I'll be able to replace the square root of x plus 4 with the square root of u, but I've got to do something with this x. So I can notice that if I let u equal x plus 4, then I can solve that for x, and I get x is equal to u minus 4. So now I can write that x over the square root of x plus 4 dx, that's called the integrate. I can write that as u minus 4, because that's what I found x to be, divided by the square root of u, and then the dx will just be du. Now I can split it up like I did in the last problem. Remember, square root of u is like u to the 1/2. So I can think of this as u over u to the 1/2 minus 4 over u to the 1/2. I still have the du. And so u divided by u to the 1/2, you subtract the exponent. So 1 minus 1/2 is just 1/2. So this will be u to the 1/2 minus 4, and I'll go ahead and write that just with a negative exponent, 4u to the negative 1/2, and then the du. Now, I'll be able to integrate this using the power rule. So I'm going to integrate u to the 1/2 minus 4u to the negative 1/2 du. So now just using the power rule, add 1 to the exponent and put it over it. 1/2 plus 1 is 3/2. When you divide by 3/2, that's the same as multiplying by 2/3. So this is going to be 2/3 u to the 3/2. Now adding a negative 1/2, adding 1 to negative 1/2 is positive 1/2. This minus 4 kind of tags along. And then multiply by, so it's positive 1/2, but I reflect it. So it's going to be 2u to the 1/2. And then you have plus c when you do that integration there. And so you can simplify that to 8, but what you want to do now is re-express it in terms of x, because the original problem was in terms of x. So you'll replace what u was with x plus 4. So this is going to be 2/3 x plus 4 to the 3/2 minus 8 times x plus 4 to the 1/2 plus